In the world, there is constant change around us. You may see the change and think that it is all the same, when in reality, there are two main types which I'll go over in today's video: chemical changes and physical changes. The more basic of these two changes is a physical change, which is something that would be easy for you to do yourself, as no new chemical bonds are formed. These changes are generally reversible and can be fixed. An example of a physical change is the change in state of matter when melting ice or freezing water, as the chemical bonds are not changed, only the intermolecular forces, and importantly, these are reversible. Chemical changes are a little more complicated though. These occur when chemical reactions occur and bonds are broken to form new bonds. These changes are generally irreversible, such as wood burning or cooking an egg. You cannot uncook an egg or unburn wood. They are not reversible as the chemical bonds are broken and the atoms are rearranged. The most important thing a chemist can do with this knowledge is identify whether a chemical or physical change occurred, and here are some good indicators. In many chemical changes, there will be a change in temperature, as there's usually a release or absorption of heat. So if there's a change that happens with a change of temperature associated, it is most likely a chemical change. But if the temperature stays the same, it is most likely physical. You may think this is contradictory to the example of ice melting I gave earlier, but in fact ice melts due to a change of temperature. The temperature doesn't change because ice melts. But when wood burns, the change in temperature is due to the chemical change. Another very tricky difference between the two is when substances are put in water. For example, glucose dissolving in water is a physical change as it changes state from solid to aqueous. Yet when sodium chloride is put in water, it is considered a chemical change as the sodium and chloride atoms dissociate and the ionic bonds are broken. So generally, when a covalently bonded molecule is put in water, it is considered a physical change as the state changes from solid to aqueous. But when an ionically bonded molecule is put into water, it is a chemical change as the ionic bonds are broken. Now that you understand the concept a little more, here are a few examples for practice. Is boiling water a chemical or physical change? How about milk curdling? Is that a physical or chemical change? Is putting an ionic compound into water a physical or chemical change? Pause the video now and think about the answers. Alright, so boiling water is a physical change as the intermolecular forces are changed and no chemical bonds are broken. The heat within boiling water is not given off by the water and is instead a cause, not an effect. Milk curdling is a chemical change as the chemical bonds break and the milk changes into something completely different in a non-reversible process. Putting an ionic compound in water is a chemical change as well, as the ions will completely dissociate and the ionic bonds that held them together in a crystalline structure are broken. I hope this video helped you decipher the difference between a chemical and physical change. And once again, this was J&A Chemistry. Have a nice day.